Folks, our game plan for today is I'm going to be giving you tips and tricks for each learning target, and we're also going to be doing some of these questions together. So first, take out your calculators if you don't have them out already. And in this first section, we are going to be solving polynomial equations. What's our easiest method of solving quadratics or polynomials?
I know. Can I get a
Factoring.
Factoring. So we want to try to factor. And what do we do if we can't factor? Then we got to do that algebraic graph solving. More on that later. So let's start with factoring. Bless you. Folks, there are three types of factoring that you need to be concerned with. The first thing we always check for is the GCF. Second, the X method or normal factoring. And then the third is grouping. Sum and difference of cubes is not going to be on the final. Hooray! So we're not going to be using that for solving. So just GCF, X method, and grouping. Algebraic graph solving, we'll go through those steps once we encounter a problem that requires it. So let's go ahead and start with number 2. Can I take out a GCF?
Number 2.
Yep.
Cannot.
We cannot. So GCF is out. We look at our powers and we go 4 to constant. This is what we called a fake quadratic. And the nice thing is we can just factor it using the X method. So factors of 3x to the 4th, 3x squared, and 1x squared. Factors of 8, let's do 2 and 4. Crisscross applesauce, we get 12x squared and 2x squared. Who needs to be negative?
2x, well.
The 12 and thus the 4. So negative 12x squared plus 2x squared gives us negative 10x squared. So remember, we're trying to get to a sum of that middle term. And then to write the factors, we go straight across. So the 3x squared gets paired with the 2. And the 1x squared gets paired with the 4. So 3x squared plus 2. And x squared minus 4. And the biggest mistake that I see on this part of the final is students just stop there and they go, woo, factored, done, baby. Are we done?
No, you have to do the x equals x equals.
We have to find what x is equal to. So, folks, that's a big part of this test is reading the directions. What we are trying to do for these problems is solve. So that means we want to find what x is equal to. And what do we call those x solutions? The x intercepts. Very good. And I wanted to bring that visualization to mind because that's going to help us when we do the algebraic graph solving. So solve and then find the x-intercepts. So we're going to set those factors equal to 0. And you could actually from that a little bit further as difference of squares. You don't have to because when we use our zero product property, 3x squared plus 2 equals 0. X squared minus 4 equals 0. 3x squared equals negative 2. Notice how we're trying to isolate our squared term. Divide both sides by 3. How do I get that x all by itself? Or how do we get a single x instead of an x squared? Square root. So x is equal to, what's the first thing we need? Plus or minus, very good. So anytime you square root is an operation, we got to have the plus or minus. Then, since it's a negative under the square root, I. And folks, we're just going to go ahead and leave it like that as plus or minus I rad 2/3. Gross. Then, for the other side, we're going to move the 4, square root. And x equals plus or minus just 2. So how many total solutions did we find? 4. So positive 2 is 1, negative 2 is 1. Positive I rad 2/3 is 1, negative I rad 2/3 is another. So this is the other thing that I'd like you to write up at the top, folks. Your degree, or the highest power in the polynomial, equals the number of roots or solutions. So what was the degree of our polynomial? 4. So the degree is 4. So that means I should have 4 solutions. And folks, as a reminder, if you go through these problems and you go, I think I need more practice, or I think I need more help with these, don't forget that this is outlined as section 5.4. So what unit is that? 5. What section is it? 4. So you can go to that part of your note packet and look at other things. You can rework through problems in your notes. All the note packet keys are on Canvas too. So if you were absent today or if you are missing pages from your note packet, all of that stuff is there for you to study. So if you want more info on that, you can look there. Any questions on this one? All right, let's go ahead and let's check this on our calculator. Folks, if I were to look at the x-intercepts for this on my calculator, how many am I going to see?
4.
2. Why? Because the imaginary ones you can't see on your graph. So I can kind of check myself on this, because if I go and I type that equation in, 3x to the 4th minus 10x squared minus 8. So if I type that into the y equals part of my calculator and I hit graph, my coordinate plane is strange. Hold on, zoom standard. This kind of calculator stuff, I would expect you to be able to do. Now, if your window gets weird or the zoom is off, I am certainly happy to help you with that. But being able to know where to type in an equation and how to look at it, that's something that you would have to know on your own. So what do we think? Is this consistent with our solutions?
Yes.
Yep, there's an x-intercept at 2. There's one at -2. And if I really wanted to verify, we can hit the trace button. Zoom out a little bit. Hit your trace button and type -2 and press enter. Boom, y value is 0. Trace +2. And we see that that is 0 as well. So you can check yourself on some of these, because let's say you accidentally had x squared plus 4 and this was plus or minus 2i then. If you graph this and you say, uh-oh, I'm seeing solutions when I thought all 4 were imaginary, that's a good way of checking yourself. So I'm taking off that last learning target in an effort to give you more time to check yourself to make sure you are doing these things accurately and precisely. So folks, let's go ahead and take a look at number 5. Do I have a GCF? No. So there's no number or variable that I can take out of all 4 of those. What's your gut telling you to do with this polynomial that has 4 terms?
Split in half.
It's grouping. So folks, up by where we wrote grouping, you may want to write 4 terms. Because how grouping works is we split it in half, and we take a GCF out of the first pair. So what is my GCF there? X squared, which leaves me with x minus 4. Now, the GCF for the second pair is a little more nuanced. What is the biggest thing I can take out of both of those? 1. So there's no like number or variable other than 1 that I can take out, but I still have to take out some GCF, so we take out 1. And then I take out the big GCF of x minus 4 from the entire expression. So the goal is to get the same item in parentheses so that you can factor that out as a GCF. And what you're left with then is the x squared plus 1. But remember, we aren't done once we factor. So see if you can set those factors equal to 0. Find your solutions. And what we should have done maybe from the get-go is look at the degree. Our degree is 3, so we should have 3 solutions. See what you can do with finding those x-intercepts. What's the square root of -1? Plus or minus. So plus or minus I, because that's what I is defined as, and 4. How many solutions did we find?
2, 3.
3 total solutions. So that's why it's a good idea to start with the degree, because that can help you identify mistakes such as missing a plus or minus or forgetting to take out an I. So those are some of the big things to be aware of in this section. So if I were to check myself by plugging this in on my calculator, which x-intercept would I see? The 4. And as we can see, dum-de-dum-de-dum, boink, there it is. It crosses at 4. So this is a way of checking yourself. So on this section, there are 2 ways of solving. You either solve by factoring, or you solve using our next method of algebraic graph solving. So folks, which one did I want to do? You know what? We'll do 7 together, and then I think I'll turn you loose on 8. So on number 7, first, what's our degree of that binomial? 3. So we should have 3 solutions, 3 roots. Now, when I try to do factoring by grouping, I take an x squared out, which leaves me with x minus 10, but is there anything I can take out of 27 and 22? No, so grouping didn't work. So grouping, fail. So we can't factor this one. This is where we use algebraic graph solving, or starting with the calc graph to find x-intercepts, and then use synthetic division to depress the polynomial. Should have left more room for that. So look at the calculator graph to find any x-intercepts that you can, and then we use synthetic division to depress the polynomial. So what we're doing is we're using a known factor to break it down into smaller factors, or ideally to a quadratic. So folks, let's go ahead, and I want everyone to try typing this in on your calculator just to make sure that there aren't any settings that we need to mess with before we go to our term test, which is what day for you guys? Thursday.
Do we need to put it in radian instead of degree?
No, leave it in degrees. Leave it in degrees in case this is the last math class you take, because you'd want it in degrees for the ACT. Seven. And you guys know when you take the final on Thursday? First block time. So you report here first thing on Thursday morning. What happens if you are gone for finals? You have to make it up. So you take an incomplete for the course, and it stays an incomplete. You have like a week or so, I think, to take the test. So you would coordinate with me and come in and take the test. If you are sick, do not come to school. Just don't do it. I will work with you. We'll find a time and a place to have you guys come and take the test. But we aren't doing the test virtually this year, so that's what happens if you get sick in the next few days. Okay. Is anybody not seeing that graph? Anybody else not seeing that graph? All right, folks, so looking at our graph, what x-intercepts do we see?
I didn't get that either. I still got it wrong.
Oh, shoot, I was looking at the old graph. So x cubed minus 10x squared plus 27x minus 22. Ooh. What a nasty little graph. So with this graph, we're supposed to have 3 solutions. We've definitely got one here that's in between. We're not going to be able to find that one exactly. In here, it looks like maybe we come up and come back down, but where does it look like we might have an exact root? Maybe at 2. So let's hit trace and try 2. And that's how we verified that 2 is a solution. So we looked at the graph. We verify with the trace button. And that's how we found our first x-intercept is 2. Now that's one solution. How many do we need to find?
2.
We need to find 3 total or 2 more. So once we've got x equals 2, what do we do with it? We put it in the box. Oh, do you guys remember the box?
Yeah.
Oh, synthetic division time. So this was the first thing that we did in term 2. So put 2 in the box. So x-intercept.
Oh.
Dude, this is so
So when you're dividing by a factor, the sign flips, but for the solving, sign stays the
What do you
same.
mean when you divide by 2?
What does that mean?
Like if I was dividing by the factor x minus 2, which is actually what we're doing here. So we're dividing by the factor x minus 2, but x equals 2 is what goes in the box. So we're not doing any straight synthetic division problems here, so keep the sign, put the x-intercept in the box.
No.
Then we list the coefficients of each term, checking for placeholders. We've got 1 for x cubed. We've got a coefficient of negative 10 for x squared. Then we've got a coefficient of 27 for x. And then negative 22 for our constant. Sweet, no placeholders necessary. Leave enough room for a second row of numbers and draw a line. Does anyone remember what we do first?
Yeah, you bring down the 1.
Bring down the 1.
Right?
What, sorry?
Like the placeholders is if it's like x cubed and then plus 27x.
Yeah, so if we didn't have that x squared there, we'd be missing that x squared power, so then we'd put a 0 in as a placeholder.
Just 0x squared.
Yep, just 0 for the x squared, yep. So we bring down the 1. Then the process from there is times the box. So 1 times 2 is 2. Write it in the second line, and then add straight down. Then times the box, negative 8 times 2, negative 16. Add straight down, 11. 11 times the box is 22, 0. And folks, your remainder should always be 0 because that's how it works when you divide by a known factor or when you put the x-intercept in the box. So if you don't get 0, it means you done goofed somewhere. So what does this do to our polynomial? It depresses it down to a smaller power. So we started with degree 3. It is now a degree 2 polynomial. So x squared goes with the 1, 1x squared. Then negative 8 gets the x, the next power down. And then plus 11 equals 0. So now we have something smaller that we try to solve. Can I factor that? We can try, but product of 11 sum of negative 8, that doesn't work. So what do we do when we encounter a quadratic that we can't factor? Oh, it's quadratic formula time. You guys ready to sing? Quadratic formula is negative b, negative 8, plus or minus the square root of b squared. Don't forget your parentheses. Minus 4, 111, all over 2a. I want you to see if you guys can simplify this. Go for it. Quadratic formula we've been using all year long, so though our final is not cumulative of both terms, quadratic formula has been around for a while. So this is kind of one of the big takeaways, along with factoring, that I would want you to have mastered in this course. So we start underneath the radical. Negative 8 squared is 64 minus 44, that's 20. So 8 plus or minus square root of 20. What do we do after we simplify what's under the radical? We simplify the radical itself. So what's the biggest perfect square I can take out of 20? 4. So square root of 4. There's the perfect square factor. Square root of 5. All over 2. So then 8 plus or minus 2 rad 5 all over 2. We don't do the division distribution until the very end. When we took this test the first time, I had some people who tried to say that this was 4 plus or minus radical 10. We cannot divide radical stuff by the stuff in the denominator. But once we get here, we can do division distribution and take a 2 out of all of those. So then x is equal to 4 plus or minus rad 5. How many total solutions did we find? 3. 4 plus rad 5 is 1. 4 minus rad 5 is 2. X equals 2 is 3. And folks, here's what's really awesome. You can hit trace and type 4 plus, oops, not that, 4 plus radical 5. Boom, 0 exactly. And 4 minus the square root of 5. Boom, 0 exactly. So if you're nervous about using the quadratic formula or nervous about all these steps, there's a lot of places where you can plug back in to check your answers. Yeah. Here's what I want you to do on your own. I want you to try number 8. Start with how many solutions should we get? Degree is 4. 4 solutions. Is there a GCF? Nope. 7 kind of messes it up for us. So no GCF. Can I do grouping? Nope. There's 5 terms, so that's out. So we are stuck as far as factoring goes. So our first step is to type that equation in on our calculator. So folks, I'm going to give you 2 minutes to get as far as you can on this one. Yep, use both of them. Depress using one in the box, depress using the other one in the box.
Do you just do either or first?
Yep, doesn't matter which one you depress with first.
I didn't get a 0.
I didn't get it.
No, I didn't get like a 0. The synthetic division, the remainder. Such a
Let me see. Yeah, video.
Oh, I did. I said 3 times 8.
All right, folks, so we start by typing it in on our calculator. So x to the 4th minus 7x cubed plus 10x squared plus 14x minus 24. Also, folks, when you go to type this in on your calculator, after I do all that button mashing, I go back and I check to make sure my equation actually matches with what's on my paper, because if your equation is wrong, then the graph's wrong, then the x-intercepts are wrong, so it's really important that you type it in correctly. And trust me, if you're running on a little bit of sleep, it is easy to make a mistake there. So we look at the graph. And how many roots do we see? 1, 2, 3, 4. However, these two are in betweeners, but it does look like we have an exact one at 3 and another at 4. Trace 3, boom. Trace 4, boom. So I have 2 exact roots, so we start with those. So x equals 3, x equals 4, and we got those from the calc graph. And now we are going to depress the polynomial just like we did on the last problem. Doesn't matter who you put in the box first, but we want to break this down until we get a quadratic. So 3 in the box. Coefficients, 1, -7. 10 for x squared, 14 for x, -24 for the constant. 1 times the box, 3, -4, -12, -2. And I like to go a little bit faster on this because I know I should get a remainder of 0, which I do. So that has broken this down to be a degree 3 polynomial, always down by 1. I'm going to go ahead and immediately put 4 in the box. I don't even have to put all my x squared stuff back in. I'm just going to go ahead and start synthetically dividing again. Boom. And what we end up with is this degree 2 polynomial.